Okay, so in this practical here, initially it wants to tell us where is the copper formed during electrolysis. Remember, copper is a metal, and therefore it is going to form a cation, and cations are attracted to the cathode. So the cathode is where the metal will form. Then we've got some results, and it says state and explain the trend in these results. So as we increase the current, the mass of copper is also increasing. So let's put that down first because that's our simple trend. So as the current increases, the mass of copper formed also increases. Okay, now the key here, we've stated it, now we've got to explain it. Why does this happen? So this happens because at higher currents, there are more electrons. Remember, a flow of electrical current is a flow of electrons. And because there's more electrons, we can get more copper ions. I'm going to put reduced. All that means is they're going to gain electrons to form copper. Okay, and that's why it happens. 3 marks, 1 for each of those statements. Okay, describe how after the power supply has been switched off, the mass of copper can be measured. Okay, so what you've got to do here, first of all, you would have to dry the electrodes. You've got to then dry the electrodes and then find the mass by using a balance. So it's 2 marks in total, 1 mark for each of those 2 statements. Okay, next little bit is a calculation. I'm just grabbing my calculator to do it. And what it wants us to do here is, in an experiment, we've got this amount of copper is being formed. Calculate the number of copper atoms in here. So let's think about the process first. If I'm going to do this, my first job is I want to convert, I want to get this into moles. And then once I know the number of moles, I then want to work out how many atoms there are. Okay, so to work out moles from a mass, we're going to use my Mr. Moles triangle. So that's our first job, is to say, right, how do I get this mass into moles? The other thing I've got to do here is be very careful because this is 74 milligrams. So 74 milligrams, but we don't work in milligrams, we work in grams. So that means it's 74 over 1000. That's how you work or convert, milligrams to grams. So you do 74 divided by 1000, which is going to be 0.074 grams. Okay, and believe it or not, there's going to be a mark in there for doing that conversion. So next job, I'm going to call that step 1. Step 2 is now let's work out how many moles of this there are. So here I'm going to put moles of the copper, and according to my triangle here, moles is mass divided by mR. So we have got the mass divided by the mR. So the mass is this new number in grams, and then the mR we're told in the question is 63.5. Okay, so divide that by 63.5, and that's given me 1.17 times by 10 to the minus 3 moles. Okay, then what I'm going to do is convert this into numbers of atoms. So I'm up to this stage here. So to do this, we're going to use this triangle here. So I want to know how many particles there are, how many atoms there are. So third step is the atoms. And according to that triangle then, atoms going to be moles times AC. So here we have got moles times AC. So the moles is this 1.17 times 10 to the minus 3. And then Avogadro's constant is given to us in the question. So we're going to work that out. So let's times that by 6.02 to the power of 23. And that is going to be 7.02 times by 10 to the 20. Okay. Marks wise, we've already given you 1 mark in there. That's going to be your second mark, and that is going to be your third mark.